Okay, so let's talk about how to graph quadratic functions in vertex form. So the first thing you're going to need to do is to graph the parent graph, which is y equals x squared. We've got a t-chart for that. -2, -1, 0, 1, 2, and then 4, 1, 0, 1, 4. We talked about that in the last chapter. So when I plot the parent graph, that would look like this. Now, I'm going to zoom in a little bit so we can see this better. There we go. Now, we're going to do the transformations now. So the first is the dilation reflection. And see that we've got this -1/2 out in front, and it's not with the x because it's not inside the parentheses. So we're going to be multiplying the y values by -1/2. The x values stay the same. We're going to multiply the y values by -1/2. I get these numbers. And now I'm going to plot those points. And that would look like that. Not the best drawing, but it works. And now I'm going to do the final step, which is the translation. So I've got a 3 inside with the x, so it's going to affect the x in the opposite way we think it should. So that'll be subtracting 3 from all the x's. And then I've got a -2 not with the x, so it does the y's in exactly the way you think it should. So subtract 2 from all the y's. So now I'm going to subtract 3 from all the x's. And I'm going to subtract 2 from all the y's. And I'm going to plot those points. -4, -2.5, -3, -2, and so forth. And connect those. And there's my final graph. So you notice this opened downward because my multiplication step involved a reflection. So that a on front is going to affect which way the parabola opens. And the numbers inside, which gave me the translation, take the vertex, which was at 0, 0, and move it to its new location. That's why this is called vertex form, because you can pretty much look at the equation and tell where the vertex is going to be, as long as you remember that what happens to the x is the opposite of what you think it should be.